We are looking at a new topic today. This is probably just a 2-lesson topic. And I want to start off by saying, if you do further maths or did further maths, probably the first 3 points here, point 1, point 2, and point 3 are stuff that will be like stuff you can do already. So if I were you, I hope you've brought further maths work with you, or maybe you've brought some other work with you. Listen to what we're doing, but it's actually going to just be recapping a lot of the things that we've done already. So you could look at some stuff from either mechanics, or you could look at stuff from from some of the integration stuff as well. Okay. If anyone who's done further maths needs a textbook, you can go and grab one from the cupboard just while I'm talking through this. Otherwise, the things that we're going to be doing now is we should start to see there are some things on this first slide that are similar to what you should have done for vectors when you were in year 12, okay? So the things that you had to do with year 12 is you had to find the distance between 2 points. That's something that you could have done from year 12, but what looks different about the coordinates or the points? Yeah, there's 3 things. So what kind of thing do you think that's telling us has changed about space? It's 3-dimensional space. So instead of talking about a 2-dimensional space, we're going to be talking about 3-dimensional space. You can see here, normally when we talked about vectors, we would only see 2 numbers and we would just have I and j. We're now going to have a third vector column, a third row in the vectors, which will refer to k, which is just because we're now talking about vectors in 3 dimensions. We're also going to be looking at the magnitude of a 3D vector and finding angles between vectors and the axes. We won't be finding angles between 2 vectors. That is something that used to be in the A-level, but has got moved to the further maths A-level. We'll be looking at solving geometric problems, which again is something that is similar to what you would have done in year 12, but I'm going to spend some time recapping that because I know it's the area that people find the hardest. And then last of all, we're going to be thinking a little bit about how it applies to mechanics. I say a little bit because we'll be doing a lot more of it when we're in mechanics. It's more just reminding us that vectors can kind of come across in this way as well. So the first thing we're going to be looking at is looking at how we find the distance from the origin and the magnitude of a vector. And this is now going to be in 3 dimensions. So if I've got this kind of example here, in 2 dimensions, how did I find the distance of a point to the origin? Pythagoras, yeah, we can clearly see that it's going to be Pythagoras. And for this particular thing we've got here, the distance would be the square root of these 2 bits, which is just 3 squared plus 4 squared, which we know just gives us that the distance is 5. Obviously the magnitude, it's a 3, 4, 5 triangle. But in 3 dimensions, some of you may know how this is done already. In 3 dimensions, you probably may have looked at finding the distance of a 3-dimensional coordinate to the origin in GCSE. This may have been something that you looked at in GCSE. So if we kind of have a think about how this might work, this says it's got the coordinates 3, 4, 12, which means that in the x direction, it's gone along 3 spaces. It's not drawn very well to scale here. The y direction, it's gone along 4 spaces. And in the z direction, which is the upwards axis, it's gone up 12 spaces, okay? So the diagram here is a little bit difficult to see. You can see this cuboid that's in 3 dimensions, and it's kind of going backwards into the board. That's what that thin orange line is saying. It's like a cuboid that's going backwards into the board. And I've highlighted from this corner of the cuboid, which is the cuboid that's kind of set backwards, I've highlighted this triangle that's in here. This triangle it's kind of like going halfway across the box. It's like if you imagine this was like a cardboard box, that triangle is going from one corner of the box to the other corner of the box like this. It's kind of like cutting through both of them. It's a little bit difficult to visualize. So if I know that this side here is 3 long and this side here is 4 long, how could I find the length of the bottom of that triangle? I'm going to do Pythagoras. So the length of this bottom part of the triangle here, I'm going to just say would be the square root of 3 squared plus 4 squared. Okay? Yes?
So does that mean that triangle bit that you just highlighted is always a right angle triangle?
Yes, and it will be a right angle triangle because of the fact that the base of this cuboid and the side bit here are going to be perpendicular to each other. So this distance that's running along the bottom here is the square root of 3 squared plus 4 squared. You're going to see why, though, I'm just leaving it in that form. I'm not actually going to work it. I know that the answer is 5. Now I'm trying to find out, let's do this in a different colour so it may make a little bit more sense. I'm trying to find out, why is it not changed? The length of the hypotenuse of this orange triangle, this kind of 3D one. What's the height of this side of the triangle? It's 12. Okay, so the distance, which is the hypotenuse, the distance is the square root of 12 squared, but I'm not actually going to do that. I'm going to say this squared, okay? This squared is 3 squared plus 4 squared. So, in fact, I might actually take that a little bit slower. It's the 3 squared plus 4 squared, all squared. So, if we simplify that a little bit, the distance is, this thing squared is 3 squared plus 4 squared, and we've got the 12 squared there. So the reason I never put this into 5 is because then I wanted you to see at the end that to find the 3D distance, you take the x coordinate, you square it, you take the y coordinate, you square it, you take the z coordinate, you square it, you add them all together and you square root it. It's like a 3D version of Pythagoras. Students often think the 3D version of Pythagoras is going to involve cubing and cube rooting, but it doesn't. It's actually just really simple. You just add in the other coordinate to be able to find that. That's how you find the magnitude. And it would be the same thing if you were going to have something that was in 4 dimensions or n dimensions to find out how big something is. You square them all, add them, and square root them. Now this actually, if we were going to go to the simplifying bit, we would have 3 squared plus 4 squared plus 12 squared. When we square root all of that, I think is the square root of 169, which is 13. This one just happens to be a nice one that is just all square rooted there, okay? So even if we don't get like a deep understanding of what's happening here, the main thing is if you want to find the magnitude of one of these vectors, you can just take each part of its component, you can square them, add them, and square root them. And what I've written here, just as a reminder of some of the notation, I've said from year 1, you will be familiar with the magnitude of a vector A being its length, and this idea extends to 3D. So whenever you're asked to find something like this, the magnitude of a vector, those lines actually mean just find the length of that vector and do Pythagoras. That tells you what the length of it is. It also tells us then if we want to find out the distance of a coordinate to the origin, you just square all the bits together, add them, and square root them. Okay? So 3D Pythagoras, actually nice and easy. Right, what about if we were going to find the distance between 2 points? How would you normally find the distance between 2 points when it was just in 2D? Muzakir?
See what goes from 3 to 2, like from 43 is 1.
Yep.
From minus 24 is 5.
Yep.
From 74 is 5, so 3.
Yeah, and you just do the magnitude of that, okay? So if we wanted to find the distance between P and Q, we look at how the x coordinate changes, how the y coordinate changes, and how the z coordinate changes. And now we know how to find distance or magnitude. It means that we can just square root and add square, add, and square root, just like we would have done in year 12. So if we have a look at how we would do that with PQ, we can look at the differences between them. So we think that the distance is going to be, well, the difference between 3 and 4 is 1, so it's going to be a 1 squared. Muzakir said the difference between 4 and minus 1 is 5, so that's 5 squared, and the difference between 12 and 7 is also 5 squared. I haven't had to worry about whether these things are positive or negative when I'm finding the difference. Why have I not worried about finding that? Yeah, Ronak. Exactly, I'm squaring it so it becomes positive anyway. The mistake that people might make is they might have said, I don't know, oh, 7 take away 12 is minus 5, and instead of writing minus 5 squared, they might have written minus 5 squared and typed that in their calculator. What's the problem if they type that in their calculator instead of that? It's going to take away 25, whereas it actually needs to be adding on 25. So my advice to you is always just to take the positive numbers and put them in there. The examiner won't be like, oh, they've done it wrong. They've subtracted them the wrong way around. It will just give you the answer in a more like efficient, simple kind of way. So working out what that is, what does that all simplify to? Root 51. So that's just root 51. I don't think that's not going to simplify to anything, is it? And you can see what I've written here, the distance between 2 points, the change in x squared, the change in y squared, the change in z squared, all square rooted and added. Another way that I wanted to quickly talk about some of these ideas that we have here is we could think of these two things as vectors. We could think of this as the vector p, the position of p. We could think about this as the position vector of q that we have there. And this vector is pq. Can anybody remember how we find...
Minus p plus q.
Was it Kim?
It's got, from p to q wouldn't be minus p plus q.
It would be minus p plus q. The way that I want you to remember this in the future is it's just the second letter, take away the first letter. It would just be q minus p. And that will then give you what the vector pq is. So if I do that really quick, q is 4 minus 1, 7, and p is 3, 4, 12. If we work that out, we get 4 minus 3 is 1, minus 1 minus 4 is minus 5, 7 minus 12 is 5. We get the vector pq, and if I then want to find out the magnitude of that vector, I would do 1 squared plus 5 squared plus 5 squared, and I'll still get root 51. So I just want you to see those two ways of doing it. One of them is thinking about the differences between the coordinates, and one of them is about changing them into vectors and knowing that pq is q minus p. If you don't know this, if you always have to think of a triangle, you need to do a little bit of adding that to your memory, that AB is b minus a. It's always the second letter minus the first letter. Because we want to understand it, but ultimately we want to be quick at doing math. That's why we try and memorize things, to try and make our life easier. Yeah?
So why does 7 minus 12 become 5?
Thank you. 7 minus 12 should have been minus 5, yeah. So again, though, when we do the Pythagorizing, we would just do the 1 squared, 5 squared, 5 squared. Yeah, it's easy to make mistakes with these kind of things. So we've got 5 different questions here that I want you to have a quick go at. They should take you no time at all. This one. Oh, this one. The distance of 4, 0, minus 2 from the origin. So it's just 0, 0, 0. So it's just going to... And then this is a separate question. This is like question 1, 2. Yep. Bless you. Okay, probably about 30 seconds more on these. They shouldn't take long. If you want to, you can always look at the bottom part. Pretty hard in further maths. I'd say it's one of the more challenging topics, and it used to be in the old maths A level, so you're lucky it's got moved. Yes. For question 2, it's saying the magnitude of this. So those lines mean magnitude, which is saying the same thing. You're going to be doing Pythagoras to 5, 4, and 1. Okay? It looks a bit different. Okay, I think we should probably be quick enough to go through some of these ones here. They're only meant to be super quick questions. So question 1, it should be the square root of 4 squared plus 0 squared plus 2 squared. Notice how I haven't even written that bit down. So that becomes root 20 or 2 root 5. Nabil, what did you get for the second question?
Root 42.
Root 42, so that's presumably 5 squared plus 4 squared plus 1. So it's, well, it doesn't say it's from the origin, it just says find the magnitude of that vector. So that's actually not, that's saying that vector could be floating around anywhere in space, it's just saying how long is that vector line, okay? So it's root 42. The distance between these two, now I want to hear what the first bit is rather than straight to the answer. Masuma, have you done this one? Oh, okay, so what should be inside? We've got 0 and 5. Yep. Yep. Good. And so the answer is root 29. Good. This one that I've got here, Tanvir. So you've got the 1, the 0 and the 1, so you've got 1 squared and 1 squared, which is root 2. And the last one, Hisham, did you get this last one done? 3 squared plus 5 squared plus 3 squared is root, how much? 43, okay. So I was going to get you to do these two on the next page, but I actually think I'll do this top one super quick. Again, it's just another question about the distance from the origin to the point 7, 7, 7. So clearly the distance is going to be the square root of 7 squared plus 7 squared plus 7 squared, which becomes, so that's 3 lots of 7 squared, pardon? Root 147, which is 7 root 3. Yeah, that makes sense. We've got 7 root 3 units. I want you to have a quick go, though, at getting this question set up and thinking about how you would do this second question. I'll give you a minute to try and get that question started and set up, and then maybe we'll finish that bit off together, okay? So there's an unknown value in one of the coordinates. Yes.
What is K? 3 plus K or 3 minus K?
Well, it doesn't really matter because if you do 3, well, it should be a minus. Sorry, it does matter. It should be a 3 minus K, or it could be a K minus 3 because you're trying to find out the difference between them. But if it's a 3 minus K or a K minus 3, because they're getting squared, it's actually going to give you the same result in the same way that when you do minus 2 squared, you get the same as 2 squared. Okay, that seems like it could be. Okay, why don't you sub it in and see if it works? I'm going to show you, I might do it in a slightly different way, okay? Yeah. Correct. Yes. Correct. Good. Well spotted. Okay. If you haven't finished this second part off, I think it's worth us talking about this as a class. So we've been told that there are 2 coordinates A and B. We've been given both of the coordinates, and as soon as we see this one, we've obviously got an unknown value that's in there. But they tell you that the distance between them is 3 root 10 units, and it says find the possible values of K. Ronak said, oh, it definitely says values, which means I'm going to have 2 answers. If something has got 2 answers, what do you think comes into your head when it says values? Really, what's the possibility for a quadratic? We're imagining, is there going to be a quadratic here? And the answer is yes, there is going to be a quadratic, because we know this whole thing is to do with Pythagoras and squaring. As soon as we're squaring something, we know that there's likely to be a quadratic. So we know that the distance between them, 3 root 10, is the same as the difference between the x-coordinates, which is 5 and 1, so the difference between them is 4 squared. Then we've got the difference between 3 and k. What should I do as the difference between 3 and k? Okay, I could do 3 minus k squared, or I could have done k minus 3 squared. Because actually when you square 3 minus k squared, you will get 9 minus 6k plus k squared. And when you square this, you will get k squared minus 6k plus 9. You get the same thing, but just the other way around. Okay, so you could have done it with k minus 3. I probably would have done k minus 3, just because I feel like that's more familiar for my brain to kind of recognize that than I would do this. But we've done that one, so we'll stick with it. And what's the difference between the z coordinates? 5, so it's just going to be a plus 5 squared. First thing that we should do to make this easier, square it. What's 3 root 10 squared? Good, so we get 90 equals, looking at everything we've got in here, 16 plus squaring this, we just said is 9 minus 6k plus k squared plus 25. Good, we've got the quadratic as we predicted, so we better get everything all onto one side and make it equal 0. So we have k squared minus 6k plus 50 minus, is it minus 40?
Minus 41.
No, I think it should be minus 40. And Hamza, with his trusty equation solver, has got k is 10 or k is minus 4. We probably could have factorized that, but if you're quick on your calculator, why not?
Yeah.
So we've got two possible values. We've got k is 10 and we've got k is minus 4.
16. What about the 9 and the 90?
Yeah.
So I subtracted that.
In the exam, do we have to write the whole equation?
Nope.
Leave it like that.
Yeah. In the exam, because this is a really good question from Ismail. Ismail just said, shh, shh, shh. To go from this line to this line, do we need to like show the examiner more evidence for this kind of thing? If this is a vectors question, they're not really that bothered about if you can solve a quadratic equation. If the question says using algebra, show blah, 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 then you need to make sure that you're communicating your algebraic all the way through. So if it was a quadratics question, probably. But if it's just a quadratic equation that appears somewhere, use the calculator. We had an email from them saying, you know, our students, lots of students are saying, can we just use the equation solver on the calculator? They said, yes, it's there. Like it's there to make life a bit easier for you. Okay. So I know it sounds like I've been doing a lot of talking here, but I'm going to push on because we can't actually do much of the first exercise yet. We're just going to add in a couple of extra things here. We mentioned this earlier, though. What's wrong, Sufyan? All okay? So in 2D, we looked at that the I vector was 1, 0, and the j vector was 0, 1. They are unit vectors in the x and y directions. We would normally say that you have I going to the right, j going up. That's the standard notation that we would say for those things. So 8 minus 2 could be written as 8i minus 2j, because it's 8 lots of I, and it's taking away 2 lots of j, 8 minus 2. Surprise, I've already said it though. The k vector gets added in for 0, 0, 1. So 1 is the k position down there. That's what it would be for the k vector. So very quickly, I'm going to just go around and ask you to see if you can help me put these into I, j, and k notation. In fact, I'll do the first one, and then maybe someone else can do the next one. So I've got 1, 2, 3 is the same as I plus 2j plus 3k. Like, you could probably teach your baby brother this kind of one, couldn't you, really? Only thing that I want you to notice is that when I write I, j, and k, I'm underlining them. Does anyone know why I underline them? Because they're vectors. If I didn't underline them, then they might look like a variable instead. So then, Ismail, what do you think this one at the bottom is here, the 3, 0, minus 1? Yep. Good. I'm actually just going to write 3i minus k. You need to be aware that if they ever say, if something isn't mentioned, that you need to put that as a 0 quantity there. Anika, what about this one? Minus 7i plus 3j. Generally, at this stage, I prefer working with with column vectors. Okay, I don't really like using I, J, and K. If they're doing the question in I, J, and K, you can do it in column vectors, and then at the end you can put it back. Muhi?
So it would have to be -7 plus 3. Could you do 3j minus 7?
Yeah, you could do 3j minus 7, but the general, because we don't normally like starting with negatives, but you're right, for vectors though, we actually will start with the I one, usually. Be careful, they could write them the other way around.
Starting with X,
Yeah, we normally put them in that way. Okay, so putting these as column vectors, Muzaki, what should this be as a column vector?
0, 4, 1.
Good. Zubair, what should this one be? Okay, now here we've got the vector, we've got a position of A and the position of B, and we want to find out AB. I put a reminder down here about how you find these, but AB we said should be the second letter, take away the first letter. So the second letter is B, which is 4, 0, minus 1, and we're going to take away A, which is 1, 2, 3. So that simplifies, if I can do this properly, 3 minus 2 minus 1 minus 3 is minus 4. So the vector AB is 3 minus 2 minus 4. Last of all, I probably don't have enough space to squeeze this in here, but you can do all of the stuff that you used to be able to do with vectors when it was in 2 dimensions. So 3A plus 2B is going to be 3 lots of A, which is 2, 3, 4, plus 2 lots of B, which is 0, minus 1, 3. I'm running out of space here. Maybe I can move this for a second. So you know that if you have a number outside the front, it just multiplies by everything that's inside. So that gives you 6, 9, 12. And then you've got plus 2 lots of this, which is 0, minus 2, 6. So when you add those together, we get 6, 7, 18. Kind of weird that this is even a separate topic. It's just like, cool, we've added another number in, that's it. Okay, 2 more bits from me, and then it's just practice time for nearly the rest of the lesson. Do you want me to go back on the other page? No? Okay. So this time, beginning part of the question is dead easy. We've been asked to find the magnitude of this vector, and hence find A with this little hat on top of it. We sometimes call that A hat. It's called a circumflex. And it's the unit vector in the direction of A. Does anybody remember how you find a unit vector? You divide it by the magnitude. I'll quickly write that over here. The unit vector is the vector A divided by the magnitude of A. Kind of makes sense. If a vector is 5 units long, get the normal vector and divide it by 5, and it will then only be 1 unit long, which is a unit vector. A unit vector has magnitude 1. So what's the magnitude of A? No, the magnitude of this. It's 2 squared plus 1 squared plus 4 squared, which is root 21. So the unit vector A is the A vector, which is 2 minus 1, 4, all divided by root 21. You can either write it like that, or you can write it like that, or you could rationalize the denominators in those as well. This is perfectly acceptable, so is this, okay? Just to really quickly think about that, root 21 is roughly like 4 point something, so it's saying that the length of this is about 4.3 units long. If we divide it by 4.3 units, the length of it will just be 1. So that's the whole point of a unit vector, is it's got a length 1. It doesn't have that much purpose in this studies, but you would use that if you were doing engineering or if you were doing it in further maths as well. Okay, we're nearly there, and then it's just time for some practice. We've got 2 vectors here, and it's asking if this is parallel to this. How do you find out if vectors are parallel to each other? What's the property if 2 vectors are parallel? They have the same gradient, but we don't really see gradients. Pardon? Good, they are factors of each other. If they are parallel, vectors are factors of each other. Kind of makes sense if you've got a vector that's like this. If you double that vector, it goes in the same direction, but it's just twice as long. So that's why they have to be factors of each other. So we're going to quickly work out what 2a minus 3b is. So that is 2 lots of 2 minus 3, 5. Whoops, not plus. Minus 3 lots of 4 minus 2, 0. So we've got 4 minus 6, 10. And we're going to have minus 12. Careful here, this is going to be a plus 6. And this is going to be a 0. So we get minus 8, 0, 10. Now we need to decide. No, he's not in at the moment. Now we need to decide whether this is parallel to this. So the other one that we've got is 4i minus 5k, which is 4i, 0j, minus 5k. How can I try and see, are they parallel? Yeah, this one is minus a half of this one. So I could either write that 4, 0, minus 5 is equal to minus a half of minus 8, 0, 10. Or I could have written that minus 8, 0, 10 is equal to what? I could have written that it's minus 2 lots of 4, 0, minus 5. Either of these statements, and then say, so they are parallel. That's all you need to do, is you need to show that they are factors and then show that they're parallel. If they're not parallel, you just need to show that you can't do that. You just need a sentence say they cannot be written as factors. Okay? I know you've had quite a lot of stuff just crammed in there. I'm going to stop the video there and then we can do some practice.